Okay, welcome to chapter 17.3, and this is where we're going to talk about the pituitary gland and the hypothalamus, as well as the number of hormones that are associated with them. So when we think about the complex of the hypothalamus and the pituitary, you can think of it as the command center of the endocrine system. And this complex, like I said, creates and secretes several hormones that will directly produce responses in its target tissues and hormones that will regulate the synthesis and secretion of other hormones in other glands. So it also coordinates messages of the endocrine nervous system. And so particularly you'll get stimuluses from the nervous system that have to pass through this hypothalamus pituitary complex to be translated into hormones that will initiate a response. When we talk about structurally what it is, the hypothalamus is a structure of the diencephalon of the brain. It's located anterior and inferior to the thalamus, and it has both neural and endocrine functions. So it produces and secretes many hormones. In addition, the hypothalamus is related to the pituitary gland, which is a bean-sized organ that's actually suspended from it by a stem called the infundibulum, or the pituitary stalk. The pituitary gland is cradled within the sella turcica, the sphenoid bone. If you remember when we looked at those, the anatomy on visible body, you should remember where that is. And it consists of two lobes that arise from distinct parts of the embryonic system. The posterior pituitary is neural tissue, and the anterior pituitary is glandular tissue, and that actually develops from the primitive digestive tract, which then migrates up towards the brain. And so we'll get into both parts of this here. Here is a list of the pituitary hormones that we're going to talk about today. Notice that it talks about what lobe it's from, what type of chemical class it is, and its effect. But growth hormone, prolactin, thyroid stimulating hormone, adrenocorticotropic hormone, follicle stimulating hormone, luteinizing hormone, antidiuretic hormone, oxytocin, and melanocyte stimulating hormone. So we'll talk about all of those today. Let's see. We'll talk about the posterior pituitary first. And the posterior pituitary gland does not produce hormones, but rather it stores and secretes hormones that are produced by the hypothalamus. And let's talk about the hormones related. So the first is oxytocin. Remember, I will just go quickly into this because we already talked about it, but again, this is the hormone that will stimulate uterine contractions and dilation of the cervix towards the end of pregnancy. And remember, it's one of the few hormones that's regulated by a positive feedback loop. And so I think that's really all I'm going to talk about in this video because we went into depth in oxytocin a few times already. It's kind of interesting, though, that it's also thought to be involved in feelings of love and closeness, which it's always interesting to think about how emotions are actually chemically related in the body. The next is the antidiuretic hormone. And once again, we've also talked about this a number of times. The more water reabsorbed from the filtrate, the greater amount of water that is returned to the blood and the less that is excreted in the urine. Things like that we've already talked about a number of times as well. So I think you're all pretty familiar with it. But I just wanted to point out this was the answer to one of the first discussions we did in the first topic, the first section of anatomy and physiology. Drugs that affect secretion of antidiuretic hormone, for example, alcohol, it'll inhibit the release of antidiuretic hormone, so you're not going to get uptake of water, which increases urine production. It'll lead to feelings of dehydration and that ever great feeling of being hungover. The next is anterior pituitary. So that was the posterior pituitary. Now we'll talk about the anterior pituitary. And this is the part of the pituitary that originates from the digestive tract in the embryo, and like I said, eventually migrates towards the brain during fetal development. There's three regions: the pars distalis, which is the most anterior, the pars intermedia, It's adjacent to the posterior pituitary, and the pars tuberalis, which is a slender tube that wraps the infundibulum. Remember, I just told you that the posterior pituitary doesn't synthesize hormones, but it just stores them. Well, in contrast, the anterior pituitary does manufacture hormones. However, the secretion of the hormones from the pituitary gland is actually regulated by two classes of hormones. These hormones, which are secreted by the hypothalamus, are the releasing hormones, and like they do, they stimulate the release or secretion of the hormones. Right here it says that within the infundibulum is a bridge of capillaries that connects the hypothalamus to the anterior pituitary. They call that the hypophyseal portal system, and basically just allows the hormones to be transported to the anterior pituitary without first entering systemic circulation. So it's just a quicker way to transport these hormones. The anterior pituitary produces 7 hormones, and we are going to talk about all of them in just not too much depth, but just a little bit. They are growth hormone, thyroid stimulating hormone, adrenocorticotropic hormone, follicle stimulating hormone, luteinizing hormone, beta endorphin, and prolactin. And so let's talk about all of them right now. So the first is growth hormone, and this has a number of effects basically that we've talked about in the past, but basically it is the hormone that regulates growth of the human body, protein synthesis, and cellular replication. It's also called somatotropin, but it's a protein that's produced and secreted by the anterior pituitary gland, and its primary function is anabolic. Remember, anabolic is like anabolic steroids or basically building molecules. That's anabolic function. It promotes protein synthesis and tissue building through direct and indirect mechanisms. All right, well that's all. That's good enough. That's really all I need you to know. It also will produce things like the insulin-like growth factors, and these are all things that enhance cellular proliferation, inhibit apoptosis, which again is programmed cell death, increase uptake of amino acids, which is protein synthesis, building blocks. Skeletal muscles and cartilage cells are particularly sensitive to the stimulation from IGF. So basically all you need to take away from this is human growth hormone, or just growth hormone, or somatotropin, whatever you want to call it, is necessary for development of the human body. Now, if there's dysfunction of the endocrine system and there's too much growth hormone, you get things like gigantism. A similar condition in adults is acromegaly, which is basically a disorder that results in the growth of bones in the face, hands, and feet. And then on the other side, if you have abnormally low levels of growth hormone, you get pituitary dwarfism, which is just growth hormone deficiency. So the next one is thyroid stimulating hormone, and I wonder what this one is. It's thyroid stimulating hormone is also called thyrotropin, and it's released from the anterior pituitary in response to thyrotropin releasing hormone from the hypothalamus. It triggers the secretion of thyroid hormones by the thyroid gland, and it's controlled by, of course, a classic negative feedback loop where elevated levels of thyroid hormones in the bloodstream then trigger a drop in the production of TRH and subsequently TSH. The next is the adrenocorticotropic hormone, also called corticotropin, and it stimulates the adrenal cortex, or basically the superficial layer or bark of the adrenal glands, to secrete corticosteroid hormones such as cortisol, or stress hormone. We won't get too much into that right now, but a variety of stressors can influence its release. Well, that's just stress hormone. You don't want too much of that. The next is follicle stimulating hormone and luteinizing hormone. Basically, follicle stimulating hormone stimulates production and maturation of sex cells or gametes, including the ova in women, sperm in men, and FSH also promotes follicular growth, and these follicles release estrogens in the female ovaries. Luteinizing hormone regulates ovulation in women, as well as the production of estrogens and progesterone in the ovary. So they do similar things, and you need both of them to occur in order for a normal, healthy reproductive cycle. The next is prolactin. Prolactin, if you know what the sugar in milk is, you lactose, and that might stimulate you to understand what this is, but it promotes lactation or milk production in women during pregnancy. Um, and so this is, I'll leave it there. And then we'll talk about the intermediate pituitary, which has melanocyte stimulating hormone. And basically, this is the cells that secrete the melanocyte stimulating hormone and basically produce melanin, which is the product or the thing that makes people's skin darker. And so I think I'm going to leave that there too. Really don't need you to know too much um, of the actual the what we would even call the process of this. This isn't something I'm not going to ask you, but anyway, it's important to know what you should take away is where these hormones are being released from. Is it the anterior or posterior pituitary? Things like that. But I'm going to leave the video here. We'll see you in the next one.